this section's a little complex. Complex zeros or complex roots. I'm going to use the word root and zero synonymously, and Mr. Creswell's going to get mad at me about that because they're technically different, but I don't really care because I'm older than he is. So, imaginary roots or complex roots. If 2i is a root or a zero, in other words, if I take 2i and replace the x's in an expression with it and solve it out, it'll spit back 0 when I get done. Okay, that's called a root. If 2i is a root, negative 2i also has to be a root. And if 3 plus i is a root, that means 3 minus i, its conjugate, is also a root. So if we had 4 plus I was a root, then 4 minus I also has to be a root. So when we get to finding roots and zeros, that's going to be helpful. All right, you want to start with this one?
Yeah,
then?
so we want to write a polynomial of least degree in standard form with real coefficients whose zeros include 2, 3, and I. And I think we just said if we use I, or if the root is I, then we've also got to have negative I. Does that sound right?
Yeah, it's kind of like going to the eye doctor.
Yeah, just like that, except it's actually nothing.
Yeah, it's an imaginary number. I apologize.
Yeah.
So if these are roots, that means x equals 2. And if I set that equal to 0, that'd be x minus 2. So x minus 2 times, and then if 3, if x equals 3, set that equal to 0, that'd be x minus 3. So my thing is always set the equations equal to 0. I'll let you keep going.
Yeah, and it's the same thing. So if I've got, x has got to equal I, right? Then I've got to have x minus I.
Yeah, because if you set this equal to 0, you bring the I over to the other side, right?
Just bring it to the other
Okay.
side. And then if I'm going to do the same thing, if x equals negative I, and I want that equal to 0, I'm going to get that I over to the other side, and I'm going to have x plus I equals 0.
Mm-hmm.
Okay.
All right, so did you catch that? I would FOIL these two first, get an answer and FOIL those two second, and take and combine. So I'll FOIL these two. We've got x squared, let's see, minus 3 minus 2 minus 5x plus 6. And that color is awful, isn't it?
Yeah.
All right.
That's all right. Let's FOIL these two. Then I'm going to have, let's see, x squared. And then I think the middle terms are going to drop out. Minus ix plus ix, those are gone. Minus I squared. I squared is just...
Yeah, so let's see, minus I squared. And the students in St. Louis have this tattooed. I squared equals negative 1.
They should, right? Yeah.
We buy tattoos for them here. It's like Ohio State. So someone says like that. In other words, you had x squared minus I squared, and we said that should be plus 1.
Right. Yeah, negative,
okay.
negative 1.
All right. So now what do we do, Mr. Creswell? Well, personally, I would probably take the x squared and multiply by each one of these terms and write those down.
Yeah.
And then take the 1 and multiply by each one of those terms.
You're really just distributing, right?
Yeah. Yeah, exactly. So take the x squared times x squared, we'll get x to the 4th. X squared times negative 5x is negative 5x cubed. And x squared times 6 is 6x squared. Then take the 1 times each of those. So
that'd be easy.
X squared, yeah, I should have given you that.
That's all right.
All right, and then I'll let you combine it like terms there.
Thanks. All right, looks like we've just got 1x to the 4th, right? How many x cubes? Just 1, so minus 5x cubed. Plus 6x squared plus an x squared. I think that gives me 7x squared. Ooh, that's good. 7x squared. Minus 5x plus 6.
Yeah. So the polynomial of least degree should be 4 because we had 4 terms, right? 4 zeros, so we're at least degree is 4. I would say that is the polynomial of least degree.
Good.
I would watch that again if I were you guys. I would watch that again, not just because we're beautiful, but I would watch it again. So last thing here, if 3 is a 0 function, multiplicity 2, that means 3 is a 0 twice. So that means x minus 3 and x minus 3 have to be part of the polynomial because 3 is a 0 twice. Peace.